The periodic table is an important chart used by scientists and engineers. The origin, organization, and analysis of the periodic table is described in this lesson. Dmitry Mendeleev created the first version of the periodic table in 1869. Mendeleev determined that each element in the periodic table has an atomic number equal to the number of protons in its nucleus. He arranged the periodic table with the elements in the order of increasing atomic number. In his first periodic table, Mendeleev organized the elements with similar chemical properties in vertical groups. About 60 elements were known to Mendeleev at that time, but he suspected that other elements would be discovered, so he left blank spaces in his original table. There are 92 naturally occurring elements. Some 26 more elements have been made in the laboratory up to the present time. This diagram shows the latest version of the periodic table. It includes the most recently discovered man-made elements. The details of how the table is organized will be discussed later in this lesson. The periodic table enables us to obtain key information on the properties of each element. As an example, information on the element fluorine, which is located in group 17 and period 2, is shown in this diagram. The name of the element is given at the top of the box. The atomic number is shown on the right and the element's symbol is prominently displayed in the center. Below the symbol is the atomic weight given to 3 decimal places. More information about how the atomic weight is calculated will be described later in this lesson. The bottom left shows the arrangement of electrons in each shell or energy level. For fluorine, this element has 2 electrons in the first level and 7 electrons in the second level. The color of the symbol is also important. A black-colored symbol indicates that the element is a solid at 20 degrees Celsius, while a red symbol shows that the element is a gas at that temperature. A blue color shows an element that is liquid at 20 degrees Celsius. Finally, a white symbol indicates an element that is synthetic, that is, man-made. 2 of the key properties of an element are the atomic mass number and the atomic mass unit. The atomic mass number is the total number of protons in the nucleus of an atom. The atomic mass unit is the total mass of both the protons and neutrons in an atom. It is always expressed as a whole number. As an example, the most abundant form of carbon on the Earth has 6 protons and 6 neutrons. This means that it has an atomic mass number of 6 and an atomic mass unit of 12, so it is called carbon-12. As shown in the diagram, the positive protons and neutral neutrons form the nucleus of the atom. The negative electrons surround the nucleus in specific energy levels as depicted by rings in this diagram. The atomic mass unit is not shown on the periodic table. Instead, the table shows the atomic weight, which is always expressed as a number that is slightly less or slightly more than a whole number. The difference is due to the fact that all elements have isotopes and carbon is a good example. In addition to carbon-12, there are 2 other isotopes of carbon in much less abundance on the Earth. They both also have 6 protons, but both have more than 6 neutrons. As shown in these diagrams, carbon-13 has 7 neutrons while carbon-14 has 8 neutrons. The atomic weight of carbon is calculated as a weighted average of the atomic mass units of the 3 isotopes depending on their abundance on Earth. This table shows how the atomic weight of carbon is calculated. The abundance of carbon-12 on Earth is 98.89%. When we multiply that percentage by 12, we obtain a weight of 11.867. Carbon-13 has an abundance of just 1.1%, so its contribution to the weight is 13 times 1.1% to give 0.143. Carbon-14, the radioactive isotope of carbon, has an abundance of only 0.01% to give a contribution of 0.001. Adding the 3 values gives the atomic weight as 12.011. This is the weighted average of the 3 isotopes and the value shown on the periodic table for the atomic weight of carbon. Since carbon-14 is radioactive, its abundance is slightly changing over time. The atomic weight of an element will vary from planet to planet because the planets were formed at different times in the history of the universe. Now we will look at how the periodic table is organized. The columns are known as groups and the rows are called periods. There are 18 groups and 7 periods. The elements in each group are shown in separate colored boxes and have similar chemical properties because they all have the same number of valence electrons. The chemical properties change from one group to another because the number of valence electrons increases from group to group. The different colors of a group of the boxes show elements that have similar properties. The total number of electron energy levels increase from one period to another. Therefore, period 1 has only 1 electron energy level, while period 7 has 7 electron energy levels. Note that hydrogen is at the very top right in a white box. This is because it has unique properties and is unlike the other elements in group 1. The elements in group 1 are called the alkali metals and include lithium, sodium, potassium, rubidium, cesium, and francium. The alkaline earth metals are included in group 2. This group includes beryllium, magnesium, calcium, strontium, barium, and radium. The next groups are considered a family and include 29 elements called the transition metals. This family includes groups 3 through 12. The white symbol denotes the synthetic element technetium and the blue symbol shows that the element mercury is a liquid. Part of group 13 shows the other metals, which includes aluminum, gallium, indium, tin, thallium, lead, bismuth and polonium. The second part of group 13 comprise what are called the metalloids. This includes boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. Groups 14, 15, and 16 include the nonmetals carbon, nitrogen, oxygen, sulfur, phosphorus and selenium. The red symbols indicate that nitrogen and oxygen are gases. Group 17 is called the halogens and includes fluorine, chlorine, bromine, and iodine. Both fluorine and chlorine are gases, while bromine is a liquid and iodine is a solid. The noble gases, all shown by red symbols, are included in group 18. They include helium, neon, argon, krypton, xenon, and radon. Period 6 has a part of what are called the rare earth elements. It includes 15 elements starting with lanthanum, so it is called the lanthanide series. One of the elements in this series is promethium, a synthetic element. The second part of the rare earth elements are listed in period 7. It starts with the radioactive element actinium, so it is called the actinide series. All of the 15 elements in this series are radioactive and elements with atomic numbers from 93 to 103 are synthetic. Finally, period 7 also includes the synthetic elements from rutherfordium with atomic number 104 to oganesson with atomic number 118. Every few years, scientists create a new element, so it is expected that this part of the periodic table will expand in the future. The current theory is that elements that make up the periodic table were created in the stars and supernova explosions. Starting with hydrogen, the elements from helium to iron were produced by nuclear fusion in stars. Elements heavier than iron were created by nuclear fusion in supernova and neutron star explosions. This presentation was produced as a public service to help middle school and high school science teachers develop experiments, presentations, and demonstrations that can be used in their classes. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. TOPS, Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by elementary and middle school students.